Hi everyone, we're Group 23. My name is Lianhao Chen, and I will give an overview about our senior design project, Psychotic-like experience, PLE prediction with deep learning. PLE is common in psychiatry and is affecting a lot of children. Our clients hope we can use machine learning to discover the medical study dataset, build up the model, and use experimental AI to understand the results to potentially help with establishing a new diagnostic tool. We also include our research into a draft paper and create a GitHub repo for future analysis. Our dataset includes 11 outcomes associated with multiple brain image datasets and one demographic and environmental non-brain dataset. Our outcome is calculated by 3 years t-score, and we will do binary classification to identify if the case has consistent distress.
There were multiple challenges during our discovery process on the datasets. First, real data is not all that clean. There are dirty data, unreasonable data, and missing data that require pre-processing. There is also only around 8,000 samples, which is not enough for a deep learning method as first expected by the client. Then we also have the problem of an imbalanced dataset, where of the 8,000 data, only less than 500 patients are distressed. The majority of the patients are healthy, as you can see from the graph here. Thus, the model will try to assign everyone to no distress by default. However, this gives no useful information. Therefore, we will need to optimize for recall or the true positives, capturing as much of the problematic patients as possible. Nonetheless, the brain dataset by itself is actually inconclusive. Here's the baseline model result optimizing for recall, and you can see that from the brain, the result is almost close to random.
Hi, I'm Somo. In order to predict the outcome, we use standard machine learning pipeline, data preprocessing, model training, model evaluation, and then using the final model for explainable AI. Specific model we used is an ensemble learning model, which combines the results of 4 simple neural networks trained on each of the datasets using a linear model. The results we get through an ensemble learning approach are way better than the baseline, as you see here. To use our code, you merely can clone the repo and pip install requirements.txt, or you can directly install pip install ABCD analysis. From there, you would then go ahead and make the ensemble classifier, set the outcome, add datasets, and then run plain test.
To understand how the model is making predictions, we try some XAI methods, and in order to get the model level explanations, we aggregate the instance level explanations we get. Also, we run clusterings to determine whether there are some prototypes across the samples in the predictions. In terms of deliverables, we have the GitHub repo, which contains all the code for generating the models and do experiment setups. Also, the report, which contains the methods we tried along the way. In addition, we also generate dashboard, which showcases the model performance and results for 20 different outcome measures.